Okay, here's what I'm going to do. What I want you to do is I want you to read in your book. All right, I'm just going to put it on here. I want you to read in your book, page 96 to like 105 or something like that. 13 pages of science, page 109. And what I'm going to do right now, I'm going to make 4 short videos where I go through the example problems that they give there. All right, so that you can understand friction. We'll do a friction problem. We'll do a tension problem. We'll do 2 friction problems. We'll do a tension problem, and you can see where this stuff comes from. And yeah, this will be good. And I'm definitely going to do one of the tension problems, and last but not least, I'm going to do towing the super trailer problem, super tanker. All right, so there we go. All right, I don't know why I had to go through all that with you. Tell you all. Okay, first problem. It's pretty easy. It's example 9. Let's just go through this one. Now this is going to be quite a few, but these will be things you can come back to later. All right. So let's look at example 9. Basically, I've got a skier. Okay. Got a ski hat on, standing on their skis. They got a very long waist. They're being pulled. Okay. There's a force that is pulling on them. Mass of the skier, 57 kilograms. All right. Static friction between the skis and the snow. Coefficient of static friction is 0.14. It is a unitless thing. It's a unitless thing. All right. So now to do static problems, because I know that the formula for the static frictional force is mu of S times the normal force, I've got to figure out what the normal force is. Okay? Find the normal force in the y-axis. So let's draw a dot. Here's my skier. Here's the center of mass of my skier. Force pulling it this way. Okay? There's a, that's one force. Weight of the skier, mg. It's another force acting on the skier. Another force is the normal force. Oh, I'll find that later. I'll find that right now. And then there's the static frictional force that's opposing the motion. All right. If we're using the static frictional force, what's the acceleration? You got it. Because static means it's not moving. So we look at the sum of the forces in the y direction. We're going to look at the sum of the forces in the x direction. And we're going to figure out the max. We're going to find F of S max. Or I think they put the max up here. Find the maximum static friction. And then all of a sudden, once it starts to move, the friction drops. All right. So sum of the forces in the y direction. Is the skier accelerating at all in the y direction? Moving in the y direction at all? No. So that's m times 0 is equal to Fn minus mg. Okay. And so 0 is equal to the normal force minus mg. So the normal force in this case is equal to mg. We're going to find cases where the normal force may not be mg. What if all of a sudden I put a mass of 30 kilograms on the back of that skier? That normal force would go up. What if this force was lifting it up like this? That normal force would go down because there'd be an extra little lifting force here. Okay? So it's not always mg. You got to analyze. So the normal force is equal to mg. Static frictional force, 0, is the acceleration in this direction is equal to 0. So I've got 0 is equal to, what are the forces? The force pulling on it minus F of S. Okay? Static frictional force, max. Pull it as hard as we can go just to make that equal. When they're right equal, when F of S max and that force are right equal to each other, just a little bit more of a nudge, it'll start to accelerate. And then F of K goes way down. All right? Aha, but wait a minute. 0, I've got F of S is equal to mu of S times F of N. So 0 is equal to F minus mu of S times Fn. But wait a minute. 0 is equal to F minus mu of S, one more substitution, times mg. So mu of S times mg is equal to the force. That'll get that thing to move. Okay? All right. Cool beans. And this comes out, so now we can plug in numbers. 0.14. Oh, it's 59 kilograms. I'm sorry. Luckily, I haven't put in any numbers yet. 59 kilograms is equal to 59 times 9.8 equal to F, and that comes out to be 81 newtons. Dun, dun, dun. Done with this one. Now we're going to be moving. Now we're going to look at a sledder going evenly.